Hi, Chemistry 30. Today we're going to talk about the redox spontaneity rule. All right, it involves making redox tables, but in a much more efficient way than we've already seen. So here's the rule. A redox reaction occurs only when the OA is above the RA in a redox table. Okay, and I'm just going to show you how this works out. So what we're going to do is construct a redox table given these three facts. Just a reminder, a redox table is a list of reduction half reactions, and it has the strongest OA at the top, and the OAs get weaker as you go down. Okay, so here's our three things that we're going to use to build the table. First one is that cobalt ions react with this indium in a redox reaction. Okay, so that means whatever the OA is in this reaction, it's above the RA. We know that copper ions react with cobalt. We also know that copper ions don't react with palladium. So let's talk about the process of turning this into a redox table. When there's a reaction, the OA is above the RA. Okay, so we just have to identify the OA and the RA here. So the way I always think about it is that the OA gets reduced. Cobalt 2 was reduced to solid cobalt. That makes it the OA. If cobalt 2 is the OA, then indium is the RA. Okay, now here's how I start building my redox table. There's a reaction, so cobalt has to be above indium. So I'm starting my redox table down here. But check it out, I'm leaving space because one of the elements might end up going in between. Okay, so right now I'm just writing their symbols. I'm not caring about what state they're in. I'm not writing half reactions yet. That's what I do at the end. All right, next up. Copper reacted with cobalt. Copper was reduced here, right? Its charge went down, which is reduction. It went from +2 to neutral. So the copper ions are the OA, cobalt's the RA. So this is my redox table I'm building. Now I know that copper has to be above cobalt. So I'll put it right here, copper. Again, with some space in case I got to put something between. Let's talk about the last reaction. Copper doesn't react with palladium. However, if it did, I'm terribly sorry. If it did, it would form solid copper and palladium ions. Okay. That means that copper would be reduced. It's the OA. Right, which matches equation 2, I think. I don't think that's too controversial here. All right, but it didn't react. So a redox reaction occurs only when the OA is above the RA. Okay, that means that if there is no reaction, that means the RA is above the OA. These are the only options, right? So if there's no reaction, we put the RA above the OA. Well, copper's at the top, so the only place for palladium to go is the very top. All right, so there's my 4 metals ranked. Okay, you'll remember the previous method of building a redox table involved putting all of these metals in ions. This one we can build with just 3 reactions. It's way more efficient. Okay, now I'm just going to finish the redox table. You do that by writing reduction half reactions. If you're not sure what an ionic charge is, just look it up in your data booklet. But most of them were given to us in the example. Okay. So what we know is that palladium 2 would be the strongest OA. Solid indium is the strongest RA. This is our redox table, reduction half reactions, and the OAs are ranked. All right, I hope this helps. Good luck.